Okay, guys, so we're going to go ahead and proceed to the cam of the teardrop bushing assignment. Okay, so this is how we're going to set up the cam. We're going to say that our stock size is 3 inch by 1 inch tall and is cut 5.6 inches long. Okay, so pretty much 3 inch by 1 inch flat bar, solved at 5.6 long. Okay, so we're going to have a 4-inch face cutter to face the part. We're going to have a 3/4 inch drill to drill the hole for the end mill to drop into. And we're going to have two 3/4 inch end mills, one for roughing and one for finish. Then we're going to have a groove tool to cut the snapper and groove. And we're going to have a center drill, doesn't really matter which one. A 21/32 drill, that's the pre-drill size for the 3/4 10 UNC tap. Okay, so our stock size is 3 inch by 1 inch by 5.6 inch tall long. So our stock size is 3 inch by 1 inch by 5.6 inches long. Okay, so the first thing we're going to do is we're going to go to manufacture. Make sure your part's saved. Good idea. And I'm going to go to setup. So with me being on milling, I'm going to go ahead and go to stock. And I'm going to do a fixed size box. The width. We're going to say it's 5.6. The Y will stick to 1 inch and the Z 3 inches. Okay, now that's with the origin in that orientation. Alright, so that's going to change. Alright, let's go ahead and we're going to set up our face of the part. So I'm going to click on model orientation and I'm going to use the Z-axis with the X-axis plane. So this is my Z. X kind of came up in the right direction by default, so that's good. And I'm going to go ahead and go back to stock here. And if you put it in front view, you can kind of get a glimpse of everything centered to the stock. Okay, now we're going to change that on our what they're calling the height right here. Let's put this offset from the top. Okay, so let's make that 0. So it looks something like that. Now I say that I want to face. Now this is carbon steel, so 30 thousandths depth of cut is good for finish. So I'm gonna do is go 0.03. All right, and you notice it offset up. Okay, that's with the model position offset from top. So pretty much what we're gonna do is we're gonna face 30 thousandths off of it, and we're not through yet. We're gonna go back to the setup on the stock point right here. We want to do okay, so I'm going to select my origin. Go ahead and set it right there. Actually, you know what? Let's. Alright, so I'm going to go ahead and set my origin and I'll put it back here. Looks like a good spot. Alright, so we'll go ahead and hit OK. And we now have our stock set up. So I'm going to rename this setup Op1 and okay, so first thing I'm going to do is I'm going to face it. So I'm going to go over here to face, and I'm gonna set up a tool. I might already have one. Let's just go ahead and set up another one. So I'm gonna go to new mill tool. We'll make it tool number 1. I'm gonna name it my 4-inch face mill. I'm going to find the face mill cutter. I'm going to change the diameter to 4 inches. Speeds and feeds. I'm going to go 600 RPM at 20 inches a minute. Go ahead and hit OK. Alright, so the stock contour looks good. Height, we're going to go to our model top. So that'll actually work out fine. I like to change these all to 100 thousandths above each other. So that looks good. Alright, so I'm only taking 30 thousandths depth of cut. So we're just going to take one pass. And it's going to look something like this. Let's go ahead and simulate it. Alright, so this is what the toolpath's going to look like. So I'm going to hit play. It ramps in, cuts across. And then once the tool gets halfway off the back end of the stock, it ramps back up. Looks pretty good. That'll work. Let's go ahead and hit save. Alright, so our next tool is going to be our 3/4 inch drill. So what I'm going to do is I'm going to go to drilling, and I'm going to click this surface. I'm going to go to tool, and we're definitely going to use a different tool. So I'm going to go to drill, new tool. This is going to be tool number 2 on the general tab. I'm going to name it 3/4 drill. Then I'm going to select the drill I need. So I'm going to go to drill, diameter 0.75, speeds and feeds. I'm going to go 900 RPM at 6 inches a minute. And we'll hit OK. Hit OK once again. Okay, so I have that surface selected right there. So it's going to cut in the center of this hole right here, right? So I'm going to give my height. Now, this is what I want to watch out for. I want my feed height to be the model top, okay? My retract height is going to be based off of model top. Make it 0.1. And my clearance height will also be 0.1. Alright, so bottom height right here. Now if you notice, you can see a little preview. It's not going through the part. Not only do we want to go through the part, but we want to go through the stock. So we have chip evacuation when we come in and start using the end mill to interpolate the bored hole. Right? So bottom height, I'm going to put that on stock bottom. And I'm going to select drill tip through. And I'm going to go extra 100 thousandths. Alright, so we'll go ahead and hit OK. And we should have something look like this. Simulate it. Pop. And you can see the tool went down. Alright, so we'll go ahead and name these. I don't have to, I'm kind of picky. We'll name this 0.75 drill. Alright, so next we're going to use our 3/4 end mill, and if you look at the stock, we have to cut out this irregular shape, okay? Now usually I like to use a pocket or a 2D contour, but because there's less stock to remove on this edge versus this corner where you have quite a bit of stock to remove, you don't want your tool paths to be consistent. You don't want to cut 100 thousandths at a time all the way around the part. What you want to do is you want the tool path to adapt to the stock geometry it needs to be removed, right? So where we're going to use that, we're going to use our adaptive clearing. So I'm going to go to 2D adaptive. We'll go ahead and select the tool. The tool I'm going to use is going to be a 3/4 inch end mill. And this is going to be my roughing end mill. Cutter, flat end mill, 3/4. Speeds and feeds. We'll go 1200. Cutting feed rate. We'll go 30 inches a minute. Plunge at 25. And we'll hit OK. Hit OK again. Okay, so we're going to do adaptive clearing. Now, this is where we have to think about work holding and how we're holding the part. For right now, I'm going to go to the model bottom on my depth. And my radial will save 10 thousandths, and my axial, W my floors, or my Z, I'll save 2 thousandths, right? Now there's more stuff we gotta do, but for right now, let's go ahead and hit OK. I didn't like that. We'll select the outside contour. Alright, so if you look at the toolpath it gives me, this is what it gives me, okay? And if I hit simulate, I'll have something like this, where a tool comes in and just removes a bunch of material at one time. Looks cool. I hope you have a good end mill if you plan on going that deep and that aggressive. So let's go ahead and change this stuff. For one thing, if you look at the stock material, so we're facing 30 thousandths off, right? So let's get a calculator here. So we have 1 inch stock material, and we already faced 0.03. Okay. So right now, as is, the stock material is 0.97 thick. Okay. Now, the overall part is 0.8 deep. All right. So let's subtract that. So the part thickness is 0.8. So we have, on our second op, we have 170 thousandths. So when we cut the side material off, we still have this stock on the bottom right here, which will be 0.17. Now, we're going to say that we're going to use parallels for op 1 that bite on the stock material 1/8 inch, okay? So, if I subtract an 1/8 inch from here, I got 45 thousandths, okay? So let's do this. On the adaptive clearing, I'm going to go to edit, and on my height tab right here, my model bottom, we're going to go extra 40 thousandths, okay? And that's to make sure we don't have like a weird edge or burr, like after we finish the part completely, that all cleans up. Now, I still have to fix a couple other things. Let's go ahead and save that. Alright, so the next thing that I want to fix is my depth of cut. Now we're going to go full depth, but the way the tool engages the material, is what we're going to change. So our optimal load right now is at 0.3. So the tool, the side of the cutter, is going to engage a stock 0.3. Okay, we're going to change this to 0.02, and we'll hit OK. And now I have a tool path that looks like this. All right. So let's go ahead and save. I'm going to go ahead and simulate this from the beginning. Alright, so we drilled that hole right there for the next process. And you're about to see why. Alright, I'm going to speed this up a little bit. Alright, so get something like that, right? So we're going full depth, but we're only engaging 20 thousandths of the cutter, alright? Depending on the diameter and what kind of material, you may want to go 20 thousandths, you may want to go 100, okay? Or you may want to go 5 thousandths. It just depends on the tool and cutter you're using. Alright, so one thing you want to watch out for is you also want to make sure that tool is coming down in a good spot. That's not going to feed in from the top. Alright, so if you look at right now my tool is right there. So I'm going to single step it, goes in, and it looks good. You always want to double check the way the tool enters the material and exits the material. Make sure it's not going to crash, or you're not going to do anything that's going to break your cutter or make it not last as long. Alright, so you always want to maximize your tool life, because tools are expensive. Alright, so that's our adaptive clearing. Now, adaptive clearing is good for roughing, and if you look on my passes, I saved 10 thousandths for the radial stock, that's per side, and 2 for V height or floors. Okay, so we still have to make another pass right here. We're gonna save that for our finish tool. Alright, so next thing to do is we'll go ahead and we'll cut through this. We'll rough out this this counter bore right here. So I'm gonna go to 2D pocket, and I'll go ahead and select that one. We'll use the same end mill on our height right here. Let's see, feet height will be, yeah, that'll work. It's a little high. Come down a little bit. 100 thousandths. Okay, bottom height. We're gonna go through stock bottom plus or actually minus point of extra 40 thousandths. And notice the spiral lead-in toolpath it gave me. So I want to drop that into that 3/4 inch drill hole. So what I'm going to do is go back into the 2D pocket on the linking tab. Right here on ramp, I'm going to put, let's see, pre-drill. Now sometimes you have to do plunge. Let's go ahead and try this out. So it should go off the center, and let's try this out.